Hey, and welcome to week one of hashtag remote learning slash hashtag remote rocks. Hopefully, you had a good spring break uh, and you're nice and rested, and hopefully, you're staying healthy, staying safe. But I know uh, we could all use some sense of normalcy back in our lives. So, hopefully, ready to get back to some learning. We miss you. Hopefully, you miss us. Understandably, if you don't. But I know we're ready to get back to doing some things and hopefully seeing you guys in our office hours and on camera, uh, just to uh, get back to the swing of things. So, before we get back to learning, we got some riddles for you. So, first one, even if they are starving, natives living in the Arctic will never eat penguins' eggs. Why not? Answers in three, two, one. Because there's no penguins there. Penguins live in Antarctica. Silly. Ha. All right, a quick math one. 5 years ago, Dave was 3 times as old as his sister. Now he is only twice as old. How old is Dave now? And answers in three, two, one. Dave is currently 20 years old. Do the math, figure it out. And last one. She sells seashells. I can't even say this. All right, start over. She sells All right. She sells seashells on the seashore. How many of the letter S is in that? And answers in three, two, one. There are 0 because there is no letter S in the word that. Got you on that one. All right. Anyways, so getting to our learning, short little video of just an intro here. Okay, so let's pull up these notes. If you wanted to follow along with these notes, I did post these on Schoology, so you could pull these up and fill them out if you wanted to, or just follow along, listen along. But we are getting into our first section on our new unit of circles. Okay, so we want to first figure out, well, this is what we're going to be looking at. Okay, so our standards for our first section of circles is determine the area of a sector and determine the length of an arc. Okay, now those might seem totally new to you. You might have no idea, but that's why we're going to be talking about them. But before we get to there, we want to know why circles, right? Why do we spend a whole unit on circles? Well, if you remember back to triangles, we said we could break up any polygon, any shape into triangles. And so we can think about that basic shape, then we can know about any other shapes. Well, the same is kind of true for circles, right? We see circles all over the world every day in our lives. I'm staring at one right now, looking outside at cars. We have tires that are very useful tools. So circles, very practical, useful in life. We have our cups, right? You've been to Starbucks. You've any cylindrical vessel that you have, it's based off of a circle, right? In today's world, all the talk is about toilet paper, right? So we have toilet paper here, which we could come up with some great problems using our circle formulas, using circles, and talking about our just toilet paper. Who knew? And then last but not least, we would not have the magical Mickey Mouse without circles. I just, in my free time, I was searching some videos and there was a how to draw Mickey Mouse. And the guy just started off with drawing a ton of circles. So that's why we need circles. All right, but taking us back to middle school. So we got to start with some vocabulary here. We can't really talk about circles without knowing our basic vocabulary of circles. So what is the definition of a circle? Definition: the set of all points in a plane that are the same distance from a given point called the center. A circle is named by the center point. So if we think about that definition, right, we have the center here, Okay? And the circle only exists on this outside part. Okay? That's a common misconception that students have, is the circle is in here. That is false. The circle is only on the outside part here. Okay? And that's in this definition. So we have an infinite amount of points out here on the rim, okay, that are equidistant from this center. Okay, so we want all of the points that are the same distance away from the center point. Okay. So now that distance from that center, we give that a name. That is called the radius. So the radius here is from the center to a point on the circle. Okay. Any segment from that center to that point. So from there to there, from there to there, from there to there. Okay. Those are what we call radius, or plural, radii. Okay. So these are called a radii for plural. Now, as we know, if they're the same distance, well, then we know each radius here, they're all congruent. So they're all congruent to each other. So that, just keep that in mind as we go through some problems here. We will use that fact that every single radius is the same length. They're all congruent to each other. Okay. Now, if we put two radii together and they form a straight line from a point on our circle to another point on our circle, if that segment goes through the center, then we call that a diameter. Okay. So a diameter, as we know, is equal to 2 radius, or radii. So that will also help us in some calculations here. So just knowing those words will help us, because we use those in our calculations for other values. So moving on to here, some more vocabulary. Okay, what we're going to be finding is the area of parts of the circle and the circumference of the circle. Now, if you remember back to middle school, the area is the part that's inside your circle. So this shaded part is the area of the circle. The circumference is the distance around the circle. Okay, so if I were to measure from this point all the way around, that's what we call the circumference. Now, if this were a polygon, a square, a triangle, a hexagon, we normally call that the perimeter. Now, because this is a curved shape, we call that the circumference of the circle. But they're one and the same. Okay, so we're finding the distance around your circle. Now, to find the area, if you recall from middle school, the formula for area is pi times the radius squared. Okay, so you take pi times the radius squared, that gives you the area. Formula for the circumference, okay, there are two. We have one that most people know, 2 times pi times the radius. Okay, so you take the radius, you multiply by 2, multiply by pi, that gives you your circumference. Now, if you notice, there's the 2 and the r. If I take 2 radii, as we saw on the last slide, that's equal to the diameter. So another formula you could use is the circumference is equal to pi times the diameter. Okay, now, again, they're the same formula. Sometimes one is a little more efficient than the other. We'll see that here in a second. But if you know one, you sort of know the other. I usually default to the 2 pi r. That's just, in my mind, I always like to reference the circumference as, or from the radius, but you could always work with this guy as well. Okay. Now, in both of these equations, okay, we see this fancy symbol, this letter, pi. Now, what is pi? It's not a food that we eat. That is spelled differently. So pi here is a Greek letter. Okay, it's pi, just like alpha, beta, gamma, and delta. But what mathematicians, these Greek mathematicians, came up with, well, they saw every single circle, as we have discovered before, they're all similar to each other.
Right? We could
take this circle, we could scale it up, and we could it would lie on this other circle. So what that tells us is every single length, because these circles are similar, all of the lengths are proportional Remember that from our triangle similarity. So what that means is I could take the circumference and the diameter, and that would be equal to every single other circumference and diameter of any other circle. Well, since they saw this and they found, hey, that's pretty neat, they gave it a special symbol called pi. Okay. Now, if you remember from the middle school, okay, pi we approximate with 3.14. Now, we'll talk about, do we use 3.14 or do we use pi in our calculations? Since we have fancy-dancy calculators that have this number pi, we will normally use that pi button. It gives us a little more exact answer, because we know if I type in pi in my calculator, it actually is 3.1415926 blah 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 blah. It is never ending. It's what we call irrational. Okay, so that's why we approximate it with just 3.14. But again, something we'll talk about here in the next couple slides. Okay. All right, so just a quick review. How do I find the area of a circle? Okay, well, we gave you that formula. Area is equal to pi times the radius squared. So all we need is the radius. Well, in this case, it says determine the area of circle O, named by the center, with a radius of 5 centimeters. So we simply just take that. We take pi, plug in our 5, and we square. Now, if you remember our PEMDAS, okay, what do we have to do first? Well, before multiplication, we have to do this exponent. Okay, so I need to take the exponent first before I multiply by pi. So 5 squared is 25. And then I multiply it by pi. Now, quick side note here. Okay. Remember, if I type in pi in my calculator, I get this irrational number, this number that never ends. Okay, so at some point we have to cut it off, so it's going to be approximate, right? We're never going to get exact. If you remember when we dealt with our radicals, our radical 124, right? If I type that in my calculator, I'm going to get a rounded answer. So we will talk about exact answers and approximate answers. Our exact answer here will just simply be 25. Let me write a better 25. 25 pi. Right? We leave it in terms of pi because the second I type that in my calculator, it becomes approximate. Okay? So this is 25 pi centimeters squared. Now, reason why we want exact answers is because if I use that calculation in a later, or that number in a later calculation, right? If I use a rounded answer, I'm going to get even more rounded. But the more precise and exact I can be in my work, the more precise and exact my final answer will be. If this were my final answer, though, well, I don't necessarily know what 25 pi is. So then I'm going to type that in my calculator. I'm going to hit 25 times my pi, and I end up with 78.54 centimeters squared. Okay. Now, that also brings me to my next point. Okay, to get that answer, I typed in the pi button on my calculator, okay, which it then has a long string of numbers. It uses an exact, close to exact, as exact as your calculator can get. As we said, pi we can approximate with 3.14, but let's see what happens. If I type in 25 times 3.14, then I end up with 78.5, nothing else. Okay, so as you see, there's slightly different answers. They're pretty close, right? If we rounded to the nearest tenth, they would actually be the same number in this case. But if you use 3.14, you're not going to be as exact as we can get using the pi button. So what I suggest is on your calculator, instead of typing in 3.14, use the pi button. If you have any trouble finding that pi button, let us know. We will point you in the right direction. All right, it's on your phone. It's on Desmos. There is a pi button on every calculator, unless you have one of those really just cheap that just has the number pad. If that's the case, by all means, use 3.14. but use that pi button. All right, so that's the area. Lastly, here we want to find the circumference of this circle. Remember, the circumference is the length around your circle. So how long is that in this case, inches? Okay, so if you remember, we have two formulas. Circumference is 2 pi times the radius, or circumference is pi times your diameter. Now, in this case, it says find the circumference of circle P with a diameter of 8 inches. So if we want to be efficient, well, we already have the diameter, so why not we just plug it into here, right? So I have pi times 8, right? And then if I want my exact answer, remember that is 8 pi inches, right? I don't touch the pi button, I just tack it on the end. Now, if I want the approximate answer, then I type in 8 times pi, and that gives me approximately 25.13 inches. Now remember, that's a linear unit, so just inches, not inches squared. Okay. Now, going back to this equation, let's see what happens if I plug that in. Now I have 2 pi. Now I want the radius. Well, what's the radius here? Well, the diameter is 8 inches. Remember, the radius is just half of that, so the radius is equal to 4 inches. So I plug in my 4. Well, 4 times 2 is 8 pi. Well, if you notice, hey, those are the exact same. So again, you'll end up at the same answer. Just one may be more efficient than the other. It doesn't really matter. Okay. Now, one quick note: we could always work backwards. So let's imagine I told you that the circumference of a circle is 12 pi. I want to know what is the radius. Okay, well, if we think about using this equation, right, I have circumference, so I could plug in my 12 pi for the circumference, and then I have 2 pi. I don't know the radius, so I want to find r. And then I just solve it algebraically. Okay, so I take the pi's, if I divide by pi, those are going to cancel out. If I divide each side by 2, then I end up with a radius of 6. Okay, so just a quick side note, you might run into a couple problems where you have to work backwards, but it's the same thing. You just use your formula, plug in what you know, solve for what you're trying to find. All right, so that is your review for our circles. If you understand that, then we can jump to our next part. That is the stuff that we're actually trying to find, our sectors, our arc length. If you're having some trouble with that, please make sure that you jump online and you ask us for some help there, because you got to know how to find the area of a circle, the circumference of a circle, before you can move on to our next steps. So again, please ask for help. I know this is a weird time, but we're here to help you. Jump onto our office hours. Remember, Mr. Sutherland is from 9:30 to 10:30, and I am from 1:30 to 2:30 every single day. Just hop on, sign up, let us know that you'll be there, and we will help you out. All right, but if you're ready, jump to the next video, and we will see you there.